Welcome everyone. So in this video we will discuss a PYQ that came in net examination in June of 2023. So the examiner is asking what is the interaxial angle between the threefold axis in the point group 233. So first let us discuss the point group in question 233. Any ideas which crystal system does this point group belong to? So a lot of you may be guessing it belongs to the hexagonal system and some of you will say it belongs to the isometric system. Why do you say it belongs to the hexagon system? Because of the presence of these threefold axes, and we know that hexagon contains either threefold or sixfold axes. But when you move to the isometric system, the students who have studied the isometric system in detail, they also know that the isometric system is characterized by four threefold symmetry axes. That means both the hexagon and the isometric can contain a threefold axis. Now the trick part is the hexagon, the threefold is always the first part of the Hermann-Morgan notation. While in the isometric, the Hermann-Morgan notation is such that the initial part of the Hermann-Morgan notation can never be the threefold. It is always the second part that is the threefold axis. So if you look closely, you can see that the threefold is not the first part. That is why this belongs to the isometric system. So 233 belongs to the isometric system. But there is a catch again. What is the catch? That there is no point group that is defined by the Hermann-Morgan notation 233. If you check your reference books, you won't find this point group. Why you don't find that? Because it makes no sense. The third Hermann-Morgan part, that is the threefold, can never coexist when you have a twofold axis and a threefold axis. That is why in your reference books you will see that the correct term for such a class that belongs to the isometric system is 2-3. You have twofold axes and you have four threefold axes in this system. So this is a mistake in the question that you have to be careful about. Now let us move back to the question. The question is asking what is the interfacial angle between the two threefold axes. So let us have a look. So in the isometric class, we have already talked about where are these four threefold axes. If you imagine a cube, all these diagonals. So if this is O, A, B, C, D, E and F, and this is G. All the opposite diagonals that you see. For example, the diagonal OC joining the upper part and the lower part behind the cube is the diagonal that we talk about. If you take AD, if you take EG, and if you take BF, so these are the four diagonals in this cube that act as a threefold rotation in every isometric system. So we know what are the threefolds that the question is asking. Let us take two of them. Let us take OC, and the other line corresponding to it would be BF. So these are the two lines in space between whom we have to calculate the interaxial angle. So in the isometric class, there is one thing that we have already discussed, that the diagonal or the threefold axes that we talk about, their angle with the vertical is about 44 degrees and 44 minutes. So this is the standard angle. We need to know this value so that we can solve such questions. So we know the angle between the vertical and the threefold is 54, 44. Let us take the other diagonal now. So if this was 54, 44, the other diagonal would also be the same angle. So the total angle between these two lines, between OC and BF, would come out to be equivalent to 54 degrees, 44 minutes into 2. So you would get something around 109 degrees. Do you see that as an option? You don't see that as an option. So that means there is some flaw in which there is some flaw in the method that we are using. What is that flaw? The flaw was we took the vertical, we took the diagonal, and we took the other diagonal, and we measured this angle. Okay. But when you talk about two lines intersecting each other, you will have two different angles. So one is this angle, the obtuse angle. There is this angle as well, that is the interaxial angle between these two lines. Let us say this is gamma. So you had beta and you had gamma, both were the interaxial angles. If this was something about 109, when you calculate gamma, what you do? You calculate the supplementary angle and you would get 71 something, right? So that means between two line segments, you will have two angles. One would be the obtuse angle, one would be the acute angle. So the obtuse angle in such a case was 109 and the acute angle was 71. Now, whenever you report any angle between two lines, for example, you are reporting the interaxial angle or the interfacial angles in crystallography, you always report the acute angle. So the acute angle was 71 something, which if you would have calculated, taking the minutes into consideration, you would land up with this value, 70 degrees and 32 minutes. So this is the correct angle. Okay. I hope this was helpful. Thank you. बंद कर दे